The last shape that it's placed on the Cartesian plane that we have to analyze is a circle. So we know the straight line when we place it on the Cartesian plane with the x and the y axis, we knew its equation. So with the straight line, we have an equation y equals to mx plus c. We could do quite a lot. With this equation, we know lots of properties of a straight line on the Cartesian plane. We made it a bit more complex, and instead of looking at the one straight line, we had 3 straight lines, and you looked at properties of triangles. Then we went into a shape that was a parallelogram, and we discussed the inclination, we discussed the extra angles, and we then discussed the angles between the lines. Now this is your last shape that we need to discuss, and that's a circle. As all shapes, it has a very specific equation, and the equation of a circle is defined as x minus a square plus y minus b square equals 2r square, where a center of a circle is given to us with coordinates a and b. Okay, so once again in the bracket we've got x minus x coordinate of a center, y minus y coordinate of a center of a circle with the radius r units. It comes from the distance between the 2 points that are, remember, if there are points that lie on the circumference of a circle, those points are equidistant from a center. They're always at the distance equal to r. So you have on the diagram 3 circles. Let's start with the easiest one, which is the red circle with the center at O, or the center at the origin. What will be the equation of the circle? Well, according to the given equation, I need to look at x coordinate of a center, which is 0, and that it's square, plus the y coordinate of a center, 0, and it's a square. Now this will be equal to the radius of a circle. Now those circles are given to us to scale, and the radius here is 4 units. All the circles have the radius equal to 4 units, so this will be equal to 4 square, which means that the simplest equation of a circle is the circle with the center at the origin, the center 0, 0. What will be then the equation of our blue circle? Well, the blue circle, the center of the blue circle has the coordinates 2 and 4, which means that the equation will be x minus 2 square plus y minus 4 square, and if the radius remains the same, will be equal to 4 square, or it will be equal to 16. Right, and the last circle that we have is our purple circle. So with the purple circle, what will be its equation? Well, the center of a purple circle has coordinates -7 and -4, and the radius of 4 units, like other two. Therefore, the equation will be x minus -7 square plus y minus -4 square equals to 4 square. So if we simplify, that last circle has the equation x plus 7 square plus y plus 4 square equals to 16. Okay, just stating an equation of a simple circle placed on the Cartesian plane. Our first basic example is example 1 on the page 254 in your textbook. You can also use the notes that I scanned for you on your lesson planner. But let's look at example 1. There are 2 questions and they're quite simple. It says determine the equation of a circle with a given center and some additional information. So if I'm looking for equation of a circle, then I know that I need to start with x minus a squared plus y minus b squared equals to r squared. So if I look at question A, the center of a circle has given coordinates 2 and 1, and the radius of a circle is 2 square roots of 3. Therefore, my equation will be x minus x coordinate of a center of a circle square plus y minus the y coordinate of a center of a circle square equals to the value of r squared. So just to simplify nicely the r value, I've got x minus 2 square plus y minus 1 square is equal to. Now just be careful, if I'm squaring the third, it will be 2 square, which is 4, times square root of 3 square, which is 3, so that gives us 12. Okay, so it's x minus 2 square plus y minus 1 square equals to 12. This example is solved in your textbook on a page 254, so you can look at this again. Question B. In question B, the center of a circle is given as 3 and minus 5, so the x coordinate of a center is 3, the y coordinate is minus 5. I don't have a given r, but I know that the circle is going through a point with coordinates minus 1 and 1. So I can start with the general equation of a circle. So I've got x minus x coordinate of a center square plus y minus minus 5 square is equal to r square. What do I need to calculate? Well, I need to find r. How would we find r? Well, we've got given a point, which means that if I substitute the given point into the curve, I should be able to find r. So it's your standard approach. How to find the last literal value, the last letter, the last unknown in a curve? By substituting the point. So if I substitute the point with coordinates minus 1 and 1, I get the following. I'm going to squeeze it in here for you. So I will have minus 1 minus 3 square plus 1 plus 5 square will be my r square. So let's simplify. So minus 1 minus 3, that's minus 4 square 16 plus 6 square is 36. So we get this equal to 52. So my r square is 52. R will be square root of 52. But they're not asking us to find r. They say state or determine the equation of a circle. So in question B, my circle will be x minus 3 square plus y plus 5 square equals to 52. Either look again on the page 254 or play this video again, but it's a simple example of how to find equation of a circle. I want you to look at very similar examples from exercise 10.3, which is on a page 256 in your textbooks, page 256. And I would like you to do the questions 1A, B, and C based on my explanation to the examples in a previous slide. So pause the video, please do the 3 examples, and then check if your calculations and your working that you're showing is all correct. Right, so you should have done the following. Because we are asked to find the equation of a circle, you should start with a general equation, so x minus a square plus y minus b square is equal to an r square should be your first step, where the center of a circle is always the one with coordinates positive a, positive b. So if I look at the answer or the question A, the center had coordinates -1 and 1. The radius was 3 units. Therefore, my equation was x plus 1 square plus y minus 1 square is equal to 3 square, or it's equal to 9. Please remember that there will always be a plus between the two brackets. If there is a minus, it's no longer equation of a circle. Question B, we had a center with coordinates 4 and -3 passing through a point with coordinates -2 and 3. So our equation was x minus 4 square plus y plus 3 square is equal to r square. And similar to the previous slides, we know the coordinates of the point, so to find r, we can substitute the given point. So I have -2 minus 4 square plus 3 plus 3 square, which is then giving me the r square. Therefore, the r square is -6 square plus 6 square. So I've got 36 and 36. I've got 72. And that gives me the general equation for question B as x minus 4 square plus y plus 3 square equals to 72. Okay, so that is equation number B. The last one, equation C, quite simple one again. We've got a center at 3 and 0. So my equation is x minus 3 square plus y minus 0 square equals 2, and it's 3 square roots of 2 as r, which I then need to square. Just to simplify the r, x minus 3 square plus y square is equal to 3 square is 9, square root of 2 square is 2, so this will be equal to 18. Okay, I hope that you are finding the introduction to equation of a circle on the Cartesian plane quite simple.